In this lesson, this is kind of the second set of examples. We're going to still try to find the 6 trig values from a certain point. Then the second problem is just a little bit different kind of a problem. Same approach, different problem. So I personally kind of like to draw a point, draw a graph on this. You could just kind of define your sine of theta is equal to y over r, figure out what the radius is, you have your y's. But you could do a point as well, so there's a couple different approaches to it. If you plot this point, you're down here at 0, -5. And typically I like to plot the point and create a triangle. Well, this doesn't create a triangle because my triangle, I always need to draw it to the x-axis. So that's not helpful. So I do have to go back to the idea that sine is defined by y over r, cosine is defined by x over r, and tangent is defined by y over x. So I have my x, I have my y, I don't have my r. So I'm going to figure out what my r is. So the equation of this circle is x squared plus y squared equals r squared. And then I'm just going to plug in what I have. So my x value is 0, 0 squared plus -5 squared equals radius squared. So that goes away. It's 25 equals r squared, square root, radius equals 5. Now, it hopefully makes sense that this thing would have been part of a circle and that distance is 5 anyway. So that would have been the radius. So there's some logic to it, but if you're not quite feeling comfortable with it, you can definitely do it that way. So we have everything that we need. So sine is y over r, which is going to make it -5 over your radius, which is -1. And then your x over r is 0 over your radius, which is 0. And then y over x is your y value divided by your x value, -5 divided by 0, which can't do, which is undefined. All right, and then the reciprocal. So the reciprocal of sine is cosecant. So we're going to be taking this and making it a fraction if you need to, and then flip it. So the reciprocal of -1 over 1 is still -1. The reciprocal of 0 is, if we make this a fraction, we would flip it and it would turn into 1 over 0, which is undefined. And then cotangent is, it's the reciprocal of undefined actually becomes a value because this is what you have and you're going to do the reciprocal of that. That's what it came from. So it would now turn into a problem looking like that, which actually is defined. So you have an answer of 0. So those are your 6 trig functions from that coordinate. A different type of problem that we have is this one, where it says find the 6 trig values where the terminal side is defined by x plus 2y equaling 0, where x is greater than or equal to 0. All right, what does that mean? Well, this is an equation, so we need to figure out what this equation looks like. So I need to kind of manipulate it a little bit and see what kind of equation we have. So we have x plus 2y equals 0. It's a linear equation of some kind, so I'm going to subtract the x over. So 2y is going to be equal to -x, divide by 2. So y equals a -1/2 x. Now there's no y-intercept, and that actually kind of has to be a thing, because when you draw this picture, it has to go through the origin, because it's going to be a radius. So that's a good sign. So our picture for this is, if we were to graph this, we would be having down 1 over 2 for your slope, down 1 over 2, and then it would go down 1 over 2, and so on and so on. And I'm only going to graph the right side because my x's need to be greater than or equal to 0. So this thing would go in this direction forever. So again, there's a couple ways to do this. We could do the definition of it, where it's just like on the last problem, you need sine is y over r. But again, I'm kind of more of a visual, so I'm going to create a triangle out of this. And so if I create a triangle out of this, I have technically an infinite amount of triangles that I create. So it seems like, well, then how am I going to lock down what the answer is? Well, all these triangles are going to be just proportionally bigger than each other. So if I just make the smallest one, I make my triangle to the x-axis. The horizontal distance is 2. The vertical distance is -1. If I went out to this one, my horizontal distance would be 4, my vertical would be -2. So it's just twice as big. So when I start doing sine, cosines, and tangents, they're just proportions. And so everything is just going to simplify back down to this basic triangle. Now what I don't know is I don't know the radius. So I'll have to do Pythagorean theorem. So 2 squared plus -1 squared equals the radius squared. So 4 plus 1 equals r squared. 5 equals r squared. So we'll square root both sides. So my radius is the square root of 5. Alright, so if we need a little bit of a bigger look to this, we're looking at a triangle that went down 1 over 2 root 5. Here's our angle. We have everything we need now. So it sounded like an ugly problem, but once you kind of, again, just kind of keep that same idea. We want to create a triangle if we can. If it's on an axis, that makes it a little harder. So that's a different approach. But we have everything we need for our 6 trig functions. So sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Opposite over hypotenuse is 1 over root 5. We're going to need to clean that up. And 2 over root 5 we're going to have to clean up as well. So we're going to have to rationalize the denominators. So we'll multiply by a square root of 5, square root of 5, square root of 5, square root of 5 to clean these up. So this is going to turn into a negative root 5 over 5. And then this is going to turn into a 2 root 5 over 5. And then tangent is going to be opposite over adjacent. -1 over 2. Reciprocals. So cosecant, reciprocal of sine. Now this is the fraction that I'm flipping, but it's easier to flip this one prior to rationalizing, because if you take this one and flip it, you're going to take your square root and put it into the denominator, and then you have to rationalize again. If you go back to this one, since it's equivalent, I can just do the reciprocal of that, and that just turns it into a negative root 5, and I don't have to put the over 1. And then same thing with cosine. Cosine is this, except this is easier to do the reciprocal of, so it's going to be root 5 over 2. And then cotangent. Cotangent's the reciprocal of -1/2, which makes -2. So the key is understanding that this is going to create you a linear equation, which means you're going to draw a picture, which also then connects to making a triangle. Once you have your triangle, you have all your pieces for your SOHCAHTOA. All right? Thanks.